Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and now in the previous video we have seen about chi-square test. In this video also we are going to see about the chi-square test. The chi-square test is nothing but we will be having with the two cases, two methods. So one method is goodness of it, we have already seen in the previous video. Now we are going to see the second method, which is number 2, which is called as the independence of attributes. This method is named as independence of attributes. So what is an attribute? Attribute is nothing but the quality or the characteristics or the behavior or the property of the given data is named as an attribute. So if n number of attributes are given, if some number of attributes are given in the data, in the raw data, we will be fixing it to be working on with the chi-square test as per the independence of attributes formula. So the given content will be like, the attributes will be named as A and B, and the content will be given as, the data will be given as small a, b, c, d. This is what our given content is. If our given content is named to be like this, then it comes under independence of attributes. So how we will calculate the expected frequencies for these type of given data, raw data. The one thing is we need to just calculate for each type of each of the given observed frequency. So first observed frequency is A here. For this particular A, what will be the expected frequency? We will just have to add up these two things and divide it by the whole number of values. So for the particular place, of A, what we will have to do is we will have to add up these two things, the first row columns, the first column elements, and you have to divide it by n throughout. So that will be the expected frequency for the particular first term A. In a similar way, we will just have an example for the D term also. If we have to calculate the expected frequency of this particular D term, we will have to just add up C and D, B and D, and divide it throughout by n. So that will be the expected frequency for the particular value D. So moving on to the degrees of freedom. What is the degrees of freedom? Degrees of freedom, since we have two rows and two columns here, that will be r minus 1 into s minus 1. R is the number of rows and s is the number of columns. So how we will calculate the chi-square calculated value? Chi-square calculated value is nothing but as usually, as we have seen in the previous goodness of it content also, summation of observed frequency minus expected frequency, the whole square, divided by the expected frequency. This is how we calculate the chi-square calculated value for independence of attributes. So if the data is given like this and if the expected frequencies are calculated like this, and as usually we can find the value of calculated chi-square test. So now we will move on to the problem given here. This is nothing but the attributes are given as favorable and non-favorable cases for the new and the conventional treatment. On the basis of information given below about the treatment of 200 patients suffering from a disease, state whether the new treatment is comparatively superior to the conventional treatment. This is what our question is. We have to check whether the new treatment is comparatively superior. Superior means we are just going to compare the independency of the two attributes given, that is new and the conventional treatment. So you are given with the data as raw data is for new treatment, the favorable cases value is given as 60, non-favorable value is given as 30. And for the conventional treatment, it is given as 40 and 70, and the total value is also given. Total is actually about to be 200. Now, how many number of rows are there? 2. How many number of columns are there? 2. What will be the degrees of freedom then? R minus 1 into S minus 1, which is 2 minus 1 into 2 minus 1, which is 1. So the degrees of freedom is 1 here. Moving on to the actual problem now, we are just going to calculate the expected frequency for the given data. How we will calculate the expected frequency for the given data? We will just add up the particular specific corresponding row and the specific corresponding column, and we will divide it by the total number n. This will be the number n. This will be 200 is your n. This will be the added up value of the row, and this will be the added up value of the column. So the expected value for the first term is 45. And again, this will be the added up value for row and column, and the expected frequency is 45. In a similar way, this for all the other atoms are calculated. So expected frequencies have been calculated using this particular table and the formula given earlier. Now what is our null hypothesis? Null hypothesis is nothing but the difference between there is no difference between the two treatments as the null hypothesis, as we have mentioned earlier. It is just not the mere statement. And alternative hypothesis, what is our alternative hypothesis? There is significant difference between the two treatments is our alternative hypothesis. Now moving on to the test statistic. What is our test statistics? The chi-square calculated. As usually we will calculate, and here for the expected frequency, what we will mention, we will be taking up all the expected frequencies from the table here, from this table, so that we will be having the expected frequencies as different values for each of the terms. But in the previous case, we will have all the values to be same for the all the observed frequencies. Now as usually we can calculate the chi-square calculated value, which is 18.18, and the tabulated value is found to be 3.841. Therefore what we can conclude on comparing chi-square calculated and chi-square tabulated, we see that it is greater than the tabulated value. And therefore what we about to know is there is much difference between the conventional treatment and the new treatment. Therefore what we can conclude, the attributes specifically say that there are differences between the new treatment and the conventional treatment, and therefore we can opt for the conventional treatment also. So this is how we perform an independence of attributes problem regarding the chi-square test. We will have one more problem in the next video as well. Thank you.